Hey there, good afternoon. This is Angie with Angie's Beyond the Lecture. And today's video is going to cover the history of the discovery on the subatomic and atomic particles. So we're talking atoms here, and also, for instance, electrons, protons, and neutrons. So again, history, I know, not very exciting, but professors and teachers will ask about these on quizzes and tests. And fear not, I went through some quizzes and tests when I was in chemistry. I only saw like maybe one or two, like one on a test and one on a quiz. But you should be familiar with, here's the bottom line. You should know the person and their contribution, for instance, what they discovered, and then also what technology they used, if any, depending on the era they were working in. And before I start, okay, so two things. One, as always, my handouts are on my website. So go there, it's linked in the video description, and you'll be able to go and see everything that I've done so far and then some. And also print it out at your convenience, follow along, during the video, whatever you'd like. And then also, I'm going to step over here. That's my cat. I put a video out yesterday on Kiki, and it had to do with her giving me this side eye, and I didn't feed her. And it got like, it was like a 15-second clip, and it got well over maybe at least 1,500 views. But anyway, I decided I'd put her on there because I thought viewers might appreciate her, seeing her, because apparently she's, had quite a few views. But back to, I'm going to go ahead and share my screen. Okay, from the top here. So I went ahead and called this the Atomic Subatomic Discovery Review Sheet. And this is going to cover, of course, the person's name, around the time they lived, what they discovered, and their contribution. And you'll see I also noted years and where they attended, like university, because a lot of them they studied out of a particular university. I think most of them were in England and or Germany, at least for this part of chemistry history, okay? And also, most of them were physicists, just FYI. So there's a lot of overlap between chemistry and physics, okay? So I'll even note like, oh, you'll see this in physics, okay? So going forward, the first person we talk about typically like in 95% of the time is this Democritus. He was a Greek philosopher, scientist, and he proposed the concept of an atom, which is just simply the smallest particle that we have. That's what he proposed, okay? Again, we call them atomos, okay? So it means in Greek indivisible. All right, so that's a question I've seen, like what did Democritus, or who is the Greek philosopher or scientist who proposed atoms? You would say Democritus, of course. Now, John Dalton, he proposed the atomic theory back in the early 1800s. He was a scientist in England, okay, and he has 5 postulates. So he's known for the 5 postulates that he proposed around this time when he was studying. And we pretty much, since he made these postulates, we've sort of refuted them, or they're not necessarily true. So, and I went through each of those 5 postulates for you, that we have those small, tiny indivisible particles called atoms. We do know, though, that we can break them down into protons, electrons, and neutrons. Then he also said, okay, if I have a given element, each of these elements that are the same have identical mass and properties. Now, we do have slight variations of elements called isotopes, which can be lighter or heavier than the accepted isotope on the periodic table. So that one was also, I guess, contested or refuted. And then we also have atoms cannot be created or destroyed, created, divided, or destroyed. And chemical reactions. Our exceptions here would be nuclear reactions, because those involve changes in the nucleus, and sometimes we split them or we fuse them together. Okay, so that would be an exception for the third one. And then when we go down to the fourth one, we have simple whole number ratios. We know elements can combine into simple whole number ratios to form compounds, and this is referred to the law of definite proportions. So no issues there per se. And then the last one, chemical reactions. Atoms are rearranged, but they don't change into atoms of another element. And we say that's largely true, though not in nuclear reactions, because when we have a nuclear reaction, we're actually, typically it's a decomposing element. So we're starting with one element and going into another one in a nuclear reaction. So remember, nuclear reactions are a little bit different in that we're modifying the nucleus in those types of reactions. Down to J.J. Thomson. So this fellow, I'm going to basically breeze through the rest of these here. I'll talk about, and again, I highlighted them for you. So J.J. Thomson, he was responsible for discovering the electron. He used cathode ray tube experiments. And I'm not going to go through the details of that. Generally speaking, you just need to know the person, what they discovered, and again, what technology they may have used at that time. So again, J.J. Thomson was responsible for discovering the electron, and he used the cathode ray tube experiments to make that discovery. Okay, and he was at Cambridge. Robert Millikan. So he's responsible for determining the charge of an electron. I have it to the right there. It's a negative 1.6 times 10 to the negative 19 coulombs. That's something you'll see in physics as well. He used the oil drop experiment, and he did his research in the good old United States. Ernest Rutherford, he went on to do some work with the nucleus and protons, and he did the gold foil experiment with alpha particle scattering. Okay, so he determined that the nucleus and proton were sort of central to the atom. We also have James Chadwick. He did some discovery with the neutron, and he used the alpha particle bombardment experiments. So he's what led us to our knowing today that neutrons reside in the nucleus. They don't have a charge. Remember, neutron, neutral, that should hopefully make sense there. And then the rest of these researchers, for instance, Niels Bohr, Erwin Schrodinger, Werner Heisenberg, we even have Max Planck down there. The rest of these researchers, they contributed more or less to electrons and how they behave. Okay, so we should know, and I'll cover this more on that final page here coming up. Electrons are what is involved, are what's involved with chemical bonding and chemical reactions. So these researchers helped pinpoint how electrons are structured on the outside of the nucleus. So we'll start with Niels Bohr. He did extensive work on the hydrogen atom, and he was able to quantize the energy levels outside of hydrogen. However, his mathematical work was not, it didn't work on the elements above hydrogen, so to speak. So more work needed to be done, and enter Schrodinger, Heisenberg, and Planck. So Schrodinger, he was out of Zurich, and he came up with the wave equation, okay? And and this basically determines the atomic orbital of whatever electron you're looking at there. And then Werner Heisenberg, he had some formulas here to figure out. He talked about or did some work on the wave function, and this has to do with the electron occupying space in 3D, travels continuously, those are affected by the nuclear charge. So he has a formula dedicated to his work. I don't think I ever had to solve any of them, but I think if you went in further into chemistry, maybe PChem or physical chemistry, you probably have to do things like that kind of math work. And then last but not least, I did throw in Max Planck. He did some additional quantum theory, energy quanta. So whenever you see quantum, that's just, for instance, quantifying something, right? And so he came up with Planck's constant at the bottom here. You'll be using that equation in chemistry, and that's where we determine the energy of a particular electron that's orbiting an atom. And he used black body radiation experiments. So ultimately, okay, so why do you have to know this? Well, you're going to be asked this on an exam by your teacher or professor. And again, you simply need to know the person's name, what they discovered, contributions. Those are kind of one and the same. And then any technology that they use, okay? If that's applicable. And the relevance here, and of course, so we're going to be tested, right? And then relevance here, these researchers contributed a lot to what we know about chemistry today. So I sort of listed out 4 highlights that help us with that. So, basically, especially the last 4 people I talked about, we now know or understand how electrons are arranged around the nucleus of an atom. We also know on the second point how different atoms emit different spectra of light, so different colors of light, and due to their specific like electron configuration or orbitals. Okay, and there will actually be an experiment, typically in chemistry 1, where you light different elements on fire and you can see the different colors that they emit. It's pretty cool, actually. And then we have chemical bonding. So, because I mentioned this before, because electrons are moving around outside the nucleus and they tend to give away or share or take electrons, it's good to know how they operate, right? So, chemical bonding, we have a better understanding there. And then, of course, quantum mechanics. So, quantum mechanics is sort of a field of physics where you're studying small particles, such as photons. And this led to technology we have these days, such as semiconductors, our MRI scanners, lasers, et cetera, et cetera. So again, I'm Angie with Angie's Beyond the Lecture. I hope you found this video helpful. And if you want to be notified when new videos come out, please hit like and subscribe. And say hello to the kitty again. All right, thanks for watching. Have a great day.